So the average was about a 39. The normal average for like the first exam of an OChem class is more like 50 to 54. So honestly, I'm not surprised. I think that that's okay. A lot of people actually did really, really well. Um, so I want you guys to keep in mind, like I posted the raw scores today. This exam was written very long on purpose. It keeps people from being able to get onto Chegg. It's kind of been proven to be one of the only things that we can do to keep our entire exam from appearing on Chegg. So that was why I did it. I'm going to give you guys an opportunity to make up some of the points on your own. And then of course there will be a curve. So I intend on giving about the same curve that I normally give, which is 10 to 15 points. I'm going to give you guys a quiz that'll open next Monday, Tuesday at the latest. That'll allow you to make up 20 points. So that's a significant amount of points that you can add to your score. So again, that quiz will open on Monday or Tuesday. I'm going to give you about 2 days to do it. And I'm telling you guys now, if I find any questions from the quiz on Chegg, Reddit, Course Hero, any of those sites, I'm not giving points. I'm giving you guys a chance to make up points for your exam. And if I find those questions and I learn that you guys are cheating to do them, that's just not okay. So please keep that in mind. Okay, so one of the things that I want to do today is actually look at some of the exam questions that really stumped people, because there were some in particular that really just knocked you guys over. The quiz next week is going to cover some material from the exam, but it's also going to be a pretty harsh OChem 1 review. One of the things that I've been talking about with the other faculty members, because we're not the only OChem 2 class happening right now, and we're not the only second semester course happening right now. Like there's Gen Chem 2 happening as well. And what we're finding is that the students who took Gen Chem 1 or OChem 1 in the spring or over the summer, like you guys had the disadvantage of the fact that part of your course was online, and this wasn't everybody, but a lot of people were able to game the system in a way that you wouldn't have been able to if the course had been in person. And that basically just means that you're not prepared for this course. And we're seeing that a lot. So I am going to test you guys a bit over OChem 1. The other thing that we're going to do today after we look at some of the tricky questions is I want to talk about how to study for this class, because I think a lot of you guys need some direction in how to prepare for an exam, ways that you can start kind of taking in the material at a faster pace and actually retaining the material. So anyway, those are the things that I want to talk about today. So for the most part, the IUPAC naming went pretty well. The questions were written so that there were kind of like obvious or not so obvious trick answers. And some of you guys fell for those, but for the most part, you guys did okay. So I'm not worried about this. What you're seeing here is just that there was a huge variety of every question, essentially. This problem you guys did okay on. It looked a lot like one that was on the exam review, and I did that on purpose so that if you worked on the exam review and had been coming to class where we worked on this problem, you would get a little bit of a boost. Okay, so this one stumped a lot of people. One of the things I think was that it says to draw out each reagent mentioned. That didn't mean in the answer, that meant like on your paper, and that wasn't very clear on my part, but a lot of you guys asked for clarification on that, and so that mostly worked out okay. But I want to read through this. So it says, Bobcat is performing an experiment. He needs to react butanal, a 4-carbon aldehyde, and also in the future, I'm not going to give descriptions of molecules. Like technically you guys have learned this naming before, but it was in OChem 1, so I gave you a little bit of a boost there. With ethyl magnesium bromide, a Grignard reagent, to synthesize 3-hexanol. He dissolved the butanol in ethanol and then added the ethyl magnesium bromide. After he was certain that all of the ethyl magnesium bromide had reacted, he added in aqueous acid. Did Bobcat's reaction work? Why or why not? So the majority of students got the overall answer correct, like no, Bobcat's reaction did not work. Where people struggled was with why. We got a huge variety of answers. Does anybody know for certain why? Does anyone feel very confident in an answer?
I think I remember putting that it got like protonated before or something, and so it didn't allow the magnesium bromide to react.
Yeah, no, that's exactly what happened. So he dissolved the butanol in ethanol. One of the things that we talked about with Grignard reagents is that Grignard reagents are strong bases and nucleophiles. So you cannot do a Grignard reaction in the presence of any sort of like protic molecule, something that can donate a proton. So what would happen if you reacted ethyl magnesium bromide with ethanol? I'm going to draw it for you real fast. So what would actually happen would be you have your Grignard and you have your ethanol and you also have your aldehyde in this mixture. What we want is for the Grignard to go and attack the aldehyde. All right, that was the goal for this. But what actually ends up happening is the Grignard is going to grab this proton and deprotonate the ethanol. From there, you end up with ethane, that's this proton, plus ethoxide and butanol. So you are not going to get the product that you want because you turned your Grignard into an alkane. So that was the answer there. That's a pretty typical type of question. I usually don't ask essay questions on exams. But again, this was all kind of just in an effort to get you guys to think a little differently because I can't really ask mechanism questions here. Oops. So that's why I wanted you guys to draw out each reagent in your notes because that would give you a chance to, see the ethanol proton. Also, most of you did a really good job of keeping it to shorter, more succinct answers. Some of you guys wrote very long essays. I don't think that was a good use of your exam time. Here were some freebie points. Most of you guys got these. This one hurt a lot of people also. It did give partial credit. So if you got some of these in the correct order, it gave partial credit, which is something that we can do with Canvas, but not with Top Hat. So I want to talk about this one just for a second. So it says, order the following carbocations in order of decreasing stability from most stable to least stable. So you're given a series of carbocations. Some of them have double bonds present and some of them do not. Is there one that is just automatically the least stable?
B.
Yeah. So B is kind of automatically number 6 because it's primary. There aren't even double bonds in that molecule, so you can't even, consider it. Oh wait, sorry. No, it's not B. I forgot about F for a second.
Okay.
Yeah. So F is vinylic, which we do not do. It's going to be really difficult to pull off that proton. B is the next one. So then from there, you need to kind of look at the other ones. I would go through and kind of take notes if I were you, because there's a lot of molecules here. So trying to, come up with the answer just, right off the top of your head is kind of difficult. I would write like, okay, this one's tertiary, this one's tertiary, this one's secondary, secondary, right? So from there, I would compare the two secondary ones because they're more likely to be the next one up. I guess we're going from the least stable because I think that tends to be the easiest. So we have C, which has the carbocation 1 removed from the double bond. What is that called?
Allylic.
Allylic. So this is secondary and allylic. What about this one?
No, it's just secondary.
Right. So this is going to be number 4. And then let's look at our tertiaries real fast, because if either of these are not allylic, then they'll probably be next. But E is allylic and so is D. So we're going to have to come back to that. That makes C number 3. Now, D and E are our top choices here. They are both tertiary. They are both allylic. What's the difference between them?
E is more substituted.
Right, so E has a more substituted double bond, and that also means that its resonance form is going to be a more substituted carbocation. So if you were to draw the resonance form of E, it's the exact same thing. And if you remember also with resonance forms, anytime that you have matching resonance forms, that's super stabilizing. So this is going to be number 1. The resonance form for D has a much more substituted double bond now, but a primary carbocation. So it's primary and allylic, but this is going to be the primary form because it's tertiary.
This is probably a dumb question, but how do you know when to do a resonance form for these? Like, how do you know?
Anytime resonance form is possible, I would check it to see if it's a better structure.
Okay.
If you were to check like the resonance forms for this, you would have gotten primary allylic. There is no resonance form for A or B or F. So that would kind of help you like
gauge it. So once but since it went from tertiary to primary, right? Or,
you're talking about D?
yeah.
Yeah, so the only reason that I put that is so that you would see that this one is less stable than this one.
Okay.
Because this is going to be the preferred form because it's more stable because of the more substituted carbocation. Remember, not all resonance forms are equal necessarily. But anyway,
okay, I got it.
Okay, yeah, so this is what you were expected to do for this problem, basically. And a lot of you actually did a pretty good job of getting things in like roughly the right quadrant, but the grading system doesn't really acknowledge that. But yeah, so if you did put F is 6 and then got everything else wrong, you got a 1/6 of the points of the problem, basically. Okay. I'm gonna clear this. Excuse me. Y'all did pretty good on is this aromatic or not. For the most part, the naming was fine. I just want to go over these notes here. I'm not usually very specific with you guys. Like I don't like agonize over spelling too much or spaces and things like that. But when we're doing an online exam, those spaces do matter. So like putting a space in between commas and numbers isn't going to be counted as correct. So I want to show you actually what this looks like. in the grading of it. So for some of them, I've actually written out like 5 or 6 different correct possible options. This one only had 2 possible correct answers. But if I were to write out, all the possibilities with spaces and stuff, there would be like 20 or 30 options just for this question. So I don't write all those out. So that's why I gave you the rules. And some of you guys just kind of failed to do the rules. So just being more careful with that. NMR, for most of you, you either got all of your NMR questions correct or you got none of them correct. Remember that you do not get to forget things in OChem, unfortunately. And these NMR questions were pretty tame. Typically, when I give an exam in OChem 2, every single exam has a couple spectra that you have to identify the compound for. So this was quite tame compared to that. This is another one that kind of kicked a lot of people's butts. I did tell you guys that I love to ask about the mechanism of electrophilic aromatic substitution. And I was very surprised at how many people did not get the 3 steps of electrophilic aromatic substitution correct. So let's just go over this for a second. What is the first step in electrophilic aromatic substitution?
Protonation of the double bond.
So before that.
Form an electrophile.
Right, so the first step is always to form the electrophile. Remember that the reagents that you're given are not actually the electrophile. They always have to be formed. And then you had to give a short explanation. You got points if you just, said what I said just now, that the reagents are not the electrophile, that the electrophile has to be formed. You got extra points if you mentioned that it's typically a Lewis acid, Lewis base interaction. What's the second step? Right, so Renee got it in the chat. It's pi attack of the electrophile. So if you mentioned that one of the benzene pi bonds attacked the electrophile to create a covalent bond to the electrophile and a carbocation on the neighboring carbon, you got full points. So basically you had to explain in words this idea. Okay, and what is the third step?
It is a hydride shift, right?
Not a hydride shift. Renee, again in the chat, chose the right word. You want to deprotonate to reform the aromaticity. So what I was looking for here was an indication that you knew that you deprotonate a hydrogen from the same carbon as the electrophile to form a double bond towards the carbocation. So I wanted you to explain in words. So this question, I didn't think was overly tricky, but most people did not do very well on it. I have told you guys many, many times, you should be using this terminology when you work through the problems. You should be drawing out the mechanisms until you understand them. When you work together, in group study sessions or whatever, you should be using the correct terminology so that you can use it as well. It also helps to make sure that you actually understand it. Okay, and then this was the other essay question. This one also got a couple of you. For the most part, everybody did a good job of determining, what was the meta director and what was the ortho-para director. If you're looking at this right now and going, wait, that I got the opposite answer of what it looks like now. There were two different versions. They were the same compounds, just flipped. So which one is meta directing, compound A or compound B here?
A.
A. So A, oops, I tried to write when I don't have the annotate open. Okay. So A is our meta director. I swear I tried to write, come on. Sorry, sometimes Zoom is not cooperative. Let me try that again. Meta director. And then what about compound B?
Ortho-para.
Yeah. Okay. So most of you guys got that. Where you messed up was the explanation. So can somebody tell me how we identify meta directors?
A partial or partial positive charge directly on the carbon directly attached to the benzene.
Right, so meta directors have positive, oh my gosh. It was working fine earlier. So meta has a positive or partial positive on the carbon or atom directly attached to benzene. What about ortho-para?
A lone pair on the atom attached to benzene.
Right, so you have to have a lone pair. Oh my gosh, I'm gonna stop writing because it doesn't look good no matter what I do. So ortho-para has a lone pair on the atom directly attached to benzene, or it can be alkyl or aryl. Other things that were accepted were electron withdrawing group versus electron donating group. You got points also for mentioning that the lone pair contributes into the resonance form, so it is electron donating through resonance. What you did not get points for was it's meta directing because it's deactivating, or it's ortho-para because it's activating. That doesn't explain to me how you know that information, essentially. But you got half of the credit for the question just by identifying those two things correctly. And then the problems, honestly, these were a mess for a lot of you guys. You need to do more practice problems. I think I've said this before, but I'm going to say it again and again and again throughout the semester. Do not use Chegg when you are doing your homework. At some point, you need to put down your notes. You need to stop using Chegg. You need to stop using a friend. You need to sit down and do the homework on your own. You need to struggle over it. And then once you finish the homework, you need to find some other practice problems. The only way that you can get good at OChem is by forcing yourself to get past that hump, right? So this kind of leads me into, oh, Allison asked about a quiz this weekend. Yes, I completely failed to actually mention that. I put it in my announcement yesterday. There is a quiz that opens today at 11, and then it closes Sunday at noon. So just make sure you have it done by noon. That has been an issue for a lot of you guys. That's an extension past what I originally promised you, so I don't give extensions if you miss that deadline, unless something really dramatic happens to you over the weekend. Okay, so now I want to talk about study habits. I'm going to open just a blank PowerPoint because clearly writing on Zoom is not working very well, but I want to be able to write. So just give me a second while I open that. Asante, I see you're the organic chemistry tutor is really good to study with. Is that something online?
He's a YouTuber. Like he does like YouTube videos of like different chemistry problems and like making it.
Okay. Yeah, I've seen that channel. I think I've shared some of his videos maybe.
No, yeah, he saved
I had
me
the
a
same
lot.
question as Alex. I was like, do you mean like the person at the Slack or?
No.
Also, I did send out an email. I know that a lot of you guys still aren't checking your emails, even though I've pretty much begged you to. The chemistry department has started tutoring as well. So these are chemistry students tutoring, and there's a schedule listed in the flyer that I posted on Canvas. Okay, I'm going to share this blank PowerPoint. It's just a place where I can write more easily. Okay, so when you're studying for OChem, excuse me, the first thing that you have to remember is that like studying with a group is a really, really good first step. And I think a lot of you are kind of skipping that step and then you're missing that opportunity. Anytime that you work with another student or another person or like a group of people, I know that, you know, it's COVID right now, but you can still do this over Zoom and stuff. Basically, you're giving yourself the opportunity to have to explain something to someone who has the same level of knowledge as you. Or you can work through some problems and kind of bounce ideas off of each other and work through the problems faster. It helps you see how somebody else who is in the exact same place as you thinks through that material. Because when you're working through problems with me in class, what I hear a lot of the time is, when you explain it in class, I get it. It sounds so simple. And then I go to do it on my own and I can't. And I guess like my only response to that is, yeah, it sounds simple coming from me because my PhD is literally in organic chemistry. It makes a lot of sense in my brain. And so I'm able to explain it very clearly. But I know that it doesn't make that much sense to you guys yet. So working with other people who are in the same place as you is a really, really good thing. And then you have your SI sessions. When you go to your SI sessions, be present. Really get what you can from Anne. Be present in the activities that you do. And, the same thing in class. I break you guys up into breakout rooms, and sometimes I go into the breakout rooms and nobody is talking. I don't know if that means you're not working on the problem, but you're definitely not doing what I asked you to do, which is basically forcing you guys to work together to try and work through those problems. So keep those things in mind. And then when you're working on your own, there's going to be a lot of times, sorry, I'll stop sharing for a second because I realize I'm making guys stare at a white screen as I talk to you. So there are a lot of times when you're working on your own, when you look at a problem and you're just kind of staring at it and you're like, I'm stuck, I can't do this. And what you've probably learned about me by now, if you've come to my office hours, is that I love a good analogy. So has anybody ever like run a race before? Like it can be, a 5K, a color run, like a half marathon. It could be anything. Mm-hmm. Has anybody ever done like anything like that? Mm-hmm. Yeah. Yes. So the thing about running a race is that if you've never run before, you can't just get up off your couch and be like, you know what? I'm going to run a 5K tomorrow. Like you can say that and you can go try to do it. It's not going to go well. It's not going to feel good. You have to put in the effort. You have to train, right? You have to go out and force yourself to learn to run a mile. And then you have to, do some strength training outside of that. You have to do a lot of things to prepare for that. I actually did that in grad school. for some reason, even though I've never been a runner and I have asthma, I was like, you know what? I'm going to run a 5K this year before Christmas. It was my New Year's resolution. And my friend was like, you can run a 5K by March. Like, just put in the effort. And then by the end of the year, we had run a half marathon. And there got to be this point where I hit like a 6-mile thing where I could not run past 6 miles no matter what I did. And it turned out that all I had to do was, when I thought I was dying, run harder, just keep running, like just literally not stop. And that was exactly the same thing that happened to me when I took organic chemistry. And I couldn't believe that I didn't notice that sooner. I just kept stopping and saying, well, I guess my body tops out at 6 miles and I'm never going to be able to do it. And that's how I felt about OChem when I took it. I would go to my faculty member's office, and I took OChem at a really small school. I went to Texas Lutheran. There were only like 25 other kids taking this. And I went to his office and he's like, you've been struggling. And I was like, yes, I have. Thanks for noticing. That's great. And I would ask questions and he would never answer me. Never, not a single time. He would go, what do you think is going to happen? And I would say, I don't know. I have no idea. And he's like, well, what do you know about this compound? Where have you seen these reagents before? And then I would have to stare at my paper forever. He would sit there in silence because his patience was like off the charts. And that is ultimately like what pushed me through OChem and what made me love OChem, was because somebody actually said, oh, look, you're struggling at something for the first time in your life. You can still do it. And that's why I ask you guys those questions when we do problems in class. Anytime that you look at a problem in organic chemistry, you're never going to have seen it before. It will always be a brand new problem. So if you expect yourself to be able to look at that problem and answer it immediately, that is asking a lot. Does that make sense? I can't tell how many people are actually paying attention because so many of your videos are off.
Yes.
But I promise you I'm getting to a point here. So
Yes.
a couple steps to learning OChem, basically. You need to learn your reagents. A lot of you guys are still really struggling with that. And that's actually what I'm going to draw some stuff out on PowerPoint for you in a second. And then once you know your reagents and you know what they do and you have that memorization part down, you have to apply it. You have to go do practice problems and you have to struggle and hate yourself and OChem and me, right? You have to go through that whole like horrible process and then move past it. So I want to show you something that you can do to learn the reagents because a lot of you are still struggling at that point. So I do not believe that OChem can be memorized. If you are trying to memorize OChem, that's not the best approach. But what you can do is memorize your reagents. And for that, flashcards are really, really useful. So let's say you're making a flashcard for some reactions. And hopefully your note cards are better than that. Okay. So we're going to have a front and a back. Anytime that you make a flashcard, it needs to be vague. It needs to be written in a way that you can look at it forwards or backwards and come up with the other side. So just be really smart about how you're doing this. So an example would be writing something like alkene plus acid plus water on one side. And then on the other, write acid catalyzed hydration of an alkene. So that's one example of creating something that kind of can be helpful. And then I would make another type of flashcard for the same reaction. On one side, I would write Markovnikov synthesis of alcohol from alkene. Or you could write like synthesis of most substituted alcohol from alkene or something. And then on the other side, write alkene plus aqueous acid. You know, give yourself the same information in a couple different ways so that you learn to recognize it, and you also learn to use the real words. You could also like put on this side like carbocation rearrangements possible, so that when you see this side, you learn to also associate the carbocation rearrangements with it. So that's one way that you can kind of start to, I guess, recognize the reagents a little better and also use the correct terminology. Another thing that you can do, I'm gonna make this a lot easier on myself, okay. A set of 2 flashcards again. So you can write reagents for bromination of benzene. And then on the other side, or not a plus sign, but so that gives you a chance to start identifying the reagents. And then you can also do something like so the important thing about the structure of this flashcard is if you see it from this side, you know that you have to come up with bromobenzene. If you see it from this side, you know that you have to come up with this, right? So give yourself a flashcard that's useful in both ways. If you just put bromobenzene on the other side, you're gonna be like bromobenzene, and then you flip it over and it's like, okay, this was about reagents, dang. You know, make it to where you can use the flashcard in a couple different ways. I want to do one more. Okay. So we also have a lot of reducing agents and oxidizing agents. And those tend to be things where people really struggle. So if you're going to do flashcards, write on one side lithium aluminum hydride. And then if you're wanting to test yourself over the abbreviations, write abbreviation. And then on this side, write the formula and the shorthand, you know, whatever it is. Give yourself a hint as to what you're looking for. And then here you could write like full name so that you know that you're supposed to come up with this. Because sometimes in a problem, I write something like this and people completely go blank. And then I ask them why, and they're like, well, I usually call it LAH. And then I just go like this, right? Not knowing the full name is not a reason to not get the question, right? Another thing you could do is strong, not reduction agent, reducing agent. And then on the other side, right, lithium aluminum hydride, and then like explain. And then you can make, you know, a set of flashcards like carboxylic acid. I'm just gonna erase. No, I won't be lazy. Okay, so then if you want to test yourself over those reactions, do not draw out a specific carboxylic acid with the reagents to come up with a specific alcohol. That's not ultimately helpful, because then if I give you a carboxylic acid that's not this, you're not going to be able to answer it. Some of you guys can extrapolate, some of you won't, you'll freeze. So I would write carboxylic acid, primary alcohol. Does that make sense? Another thing that you guys need to be able to do on your own is organize information. Sometimes I draw charts when I'm teaching the class in person. I summarize things in charts a lot, and I've seen Anne do that for you guys. All my SIs have done this for students, and I love that we can give you guys those because I think they're great study tools, but making it on your own is an even better study tool. So let's go through and create a chart here. Let's say I'm struggling with my oxidizing agents. Like, I do not know what they do. The things that we tend to oxidize, we have primary alcohols, we have secondary alcohols. You can make a line for tertiary alcohols if you feel like that's gonna help you. We have benzylic carbons, and aldehydes can also be oxidized. So make a list of things that you might see used with oxidizing agents. And then list out your oxidizing agents, but group similar ones together. So there's really only two classes of oxidizing agents. You have your mild ones, which includes PCC and swern. And then you have your strong oxidizing agents. This includes potassium permanganate, and I'm kind of shorthanding the reagents here. You want to write them out fully at some point. Jones, you can use chromic acid. What else do we know? Sometimes I blank on all the things that we know. But anyway, you kind of get the idea here, right? So then go through and tell yourself what you make. If you react a primary alcohol with PCC or swern, what do you get? What functional group?
Aldehyde.
Yeah, you make an aldehyde. And if you react it with a strong oxidizing agent, what do you get?
Carboxylic acid.
Right. So doing it this way is really great. I'm going to leave the rest of it blank for you so that you can, figure this out on your own. But organizing information this way is really, really good for you because it forces you to think of organic chemistry in broader terms. And ultimately, that's what we want for you. Because again, I've said this so many times, but when it comes to, I'll share this very awesome PowerPoint that I just made on Canvas. One of the things that I try to remind students of all the time is if you do the same practice problems over and over and you think about things in very specific terms, like you always draw out acetic acid and reduce it to ethanol. When you see some other carboxylic acid with the same conditions, you're gonna, like, a lot of people just go, I've never seen it before. I don't know what to do. But if you take it in broad terms and say carboxylic acid, strong reducing agent, primary alcohol, then you look at that compound and you say, okay, that's a carboxylic acid. I know that. And then you look at your reducing agent and you're like, that's lithium aluminum hydride. It's strong. It'll reduce anything. That's going to make a primary alcohol, right? Same thing. We're about to embark on actually like my favorite material. I love chapter 16. Chapter 16, 17, 18 are my jam. You can probably tell, like, in the mechanism videos I made, I'm really excited about it. those mechanisms start to get really, really convoluted. And I hear students all the time to be like, I don't know where to start. I have no idea. Watch that video and then write down the questions that I'm asking, because even though there was nobody in the room with me, I was like, what do we know about this compound? I asked like my bedroom. That's what you need to be doing anytime that you try to solve a problem. Like, I know that I'm in acidic conditions, so I should probably try to protonate something. And if you protonate something and you're like, that doesn't help me, protonate something else, put a proton somewhere else and see if that helps you move forward. And always ask yourself, have I seen this idea before? Have I seen this type of like set of reagents, don't get too creative. Anytime you get too creative, that's typically because you're like taking a hard left into crazy town. But anyway, I hope that was kind of helpful to a lot of you. If it wasn't, I'm sorry if you feel like I wasted a bit of your Friday, but these are the types of things that you guys need to be doing on your own. And if you didn't do well on this exam, those are some kind of concrete steps that you can take towards preparing for exam 2 and exam 3. Are there any questions?
So if we made like a really bad grade, would you say we're like doomed?
No.
I
No,
feel like I did good and
no, I have no problem admitting to my students that I always failed my first exam at OChem. Like in OChem 1, I failed my first exam. In OChem 2, I found that exam not too long ago. I think I got like a 29. I still got good grades in OChem. I still understood OChem. I understood it better in grad school, that's for sure, because I was like, you know what, I'm going to get my degree in OChem, even though it was the hardest class for me. You just have to be able to put in the work. So if you did bomb exam 1, go back over your exam and be like, what did I do wrong? What do I not know? And then once you figured out what you don't know, you can start taking concrete steps towards filling in those blanks. Also, I still have office hours every Monday, Tuesday, and Wednesday, and nobody is coming. If you need help, come to my office hours. If you can't come to my office hours, if that's why people are struggling is because like you can't come, tell me so I can change them, right? I do want to help you, but nobody's coming. And a couple people came on the Monday before the exam, I think, or maybe it was Tuesday. But we had a really good and valuable session. It was very fun, I thought. And those students actually did pretty well. So I'm not saying that was because of me. I'm saying it's because they put in the effort. So anyway, please come in.
That extra credit you were talking about, where is it? Is it already on Canvas?
No.
Okay.
No, it'll appear on Monday or Tuesday.
Okay, awesome. Thank you.
Would you say like OChem is kind of like a puzzle? Because like I understand physics because it's formulas, but I just can't get a grasp on how to like tackle chemistry.
Yeah, OChem is definitely puzzles. I was actually talking about this with somebody in office hours. One of the things that the chemistry department talks about a lot is that when we were kids, I say like I'm so much older than a lot of you. I'm older than a lot of you, but not by a lot. But when I was a kid, Sudoku was like the thing. Like it hit when I was in middle school, and like we just did not stop doing it. And I grew up doing puzzles all the time because like, it was before cell phones and stuff like that. We don't do puzzles anymore. Like a lot of people just don't do them. And then when you get to OChem, it is a puzzle like all the time. It's all critical thinking and problem solving. Like you have to know some base information. Like knowing your reagents is the equivalent of being able to count to 9 when it comes to like Sudoku, right? In Sudoku, the only background information you need is, can I count to 9? And then you have to apply it, right? Just knowing 1 through 9 does not mean that you can solve a Sudoku. It's the same thing in OChem. Just being able to know your reagents doesn't mean that you can solve an OChem problem. So, Sarah, if you suck at Sudoku, practice Sudoku. It's weird, but I've actually told this to students before, like download a Sudoku app and do one every day. and you'll actually find yourself getting better at a lot of other things in your life. Part of OChem is just forcing yourself to learn a new skill, which is problem solving. And for a lot of you, you're not going into you're not going into a chemical field, and maybe you're not going to use OChem in your everyday life. So get something out of this class. Let that be problem solving, right? I am now really, really awesome at visualization because stereochemistry was so hard for me that I spent just hours with models trying to understand it. And now, like, when we moved into our house or we were trying to like buy furniture or something, I told my husband, like, that table will fit there in that spot exactly. And he was like, will it really? Are you sure? And then, you know, we get it through the door and I'm like, bam, it goes right there. And like, is that a very important skill? Probably not, but I have it because of OChem. And every time you learn something new, it actually does forge new neural pathways in your brain, and it makes you smarter. So any skill, like if you learn to cook, you know, like anything that you do that you're not normally good at already makes you smarter. So do some Sudokus, do crossword puzzles. Although crossword puzzles, I don't really think are a puzzle. It's more like you have to know trivia. But, you know, do things that challenge your brain in a different way, and you'll find that you improve in other areas of your life, I think, especially OChem.
And what about like the basics? Because I know sometimes you can get like different answers because they can be like differently set up, but it's the same thing. Like that's another thing that kind of like messes with me.
You mean like some of the like fine exceptions?
Sort of like you can get an answer, but you can also draw it differently, but it's the same answer.
Oh, yeah, that's visualization really. That's being able to look at a structure and recognize, you know, it being flipped upside down or something. So yeah, that goes back to that skill.
Thank you.
For going over our exams, do we need to schedule time with you during office hours for us to do that?
No, I'm going to release exam 1 probably after you guys do the extra credit quiz. Because there will probably be some repeat questions from exam 1. I didn't make it immediately releasable because I did have to extend time for some people because they had like massive issues with Examity. And then there were some emergencies that people had, but so I didn't make the exam release immediately.
Okay.
But I will release it after the quiz.
Okay, thank you.
Mm-hmm.
And then if we can't get to your office hours, is it just best to email you to try to arrange that? Something.
Yeah, definitely email me and we can try to arrange something else. I typically do not make appointments in the evening just because I do work all day and I have to draw a line somewhere. Otherwise, the mental exhaustion is real with this job.
Yes.
But yeah, I can make occasional appointments and stuff.
Thank you.
Mm-hmm. Anything else? Any other questions or?
Nope. I'll see you at your next office hours.
All right, sounds good.
Thank you, Vincent Getta.
Stop the